So when we're looking at trigonometry that we learned in grade 10 is triangle trigonometry. Okay, and we're going to move into circles later on in grade 11, but for now we need to make sure we understand our triangle trigonometry. So our triangle trigonometry is based on this right triangle, and this right triangle holds the Pythagorean relationship. So if I need to solve for this unknown x here, what I can do is I can use the Pythagorean theorem. So to solve for x, I can say that x squared is going to be the sum of these two squares off of the shorter sides. Okay, so when I calculate x squared, so 19 squared plus 14 squared, 19 squared plus 14 squared gives me 557. Okay, so x squared equals 557. So the length of x is going to be plus minus square root 557, but since we're dealing with the length, we're just going to use square root 557. Now, if you're used to converting that to decimal, we want to try to get out of that habit, okay, because we want to start using exact values. But as a decimal, this is about 23.60. Okay, it's approximately, but we really want to stick with this value. That value is much more useful to us. Okay. So once we find out that third side, we can start finding the angles. In fact, we could actually find the angles before we find the third side. So if I want to find an angle, we have to remember that trig is about expressing an angle as a ratio. Okay, so we can say that this angle here is defined by the length of this rise and run. Okay, so we can say rise and run. So we can describe that angle as a ratio, but we can also describe it with angular degrees. And basically, there are just two different ways to express the same thing. So we have ratio, we have angle. And if I want to convert angle to ratio, this is what I normally do. I use sine cos tan. Okay, so I'm going to go in this direction here, like that. We use sine, cos, tan. But I can also go in the other direction. I can go from the ratio and describe that same thing with an angle. Really, they're just, again, they're really describing the same thing, but they're kind of talking two different languages. And we need to be able to convert from one to the other. And we can convert by using sine, cos, tan going one way. And to go the other way, we use the inverse sine, the inverse cos, inverse tan. And that's something that we know in math, that if I can do something one way, I can undo it with an inverse. So if I want to find out the angle A, I'm going to use an inverse. I'm going to set it up this way. I'm going to take the inverse tan of 19 over 14. So there's my tan ratio. Here's my ratio. I'm going to input it into my sine inverse tan ratio. So I'm going in this way, my inverse tan function, and my output should be an angle. So when I put this into my calculator, okay, typing this into my calculator, I go inverse tan of 19 divided by 14. I get an angle of 53.6 degrees. Okay, now not that this picture is super accurate, but that seems reasonable, of 53.6 degrees. Okay, so if that's the case, I can find angle B. I can use trig to find it, but I can also just know that these are what we call complementary angles. These add up to 90 degrees. So I can subtract from 90 degrees. So 90 degrees minus my 53.6 degrees gives me 36.4 degrees. So that angle is 36.4 degrees. Okay. Now, when I talk about sine, cos, and tan, well, once I have the angle, I could just type it into my calculator. However, that's not what's implied. Okay, so what's implied is we use a ratio. Sine, it actually represents a ratio. When I say sine A is the angle, sine A is the ratio. And I want to know the ratio of the opposite side, 19, compared to the hypotenuse side, which is 500, square root of 557. Now, if I actually work this out of the decimal, which we really don't want, we want to keep the exact values. So 557, I get 0.805 approximately. Okay, as a decimal, this is approximately equal to 0.805. And there's my ratio. And my calculator, if I know the angle 53.6, I can actually use my calculator. And in here is my calculator. Okay. My calculator does this translating. And I can actually get the same decimal by going tan of 53.6 degrees. Okay, sorry, sine of 53.6 degrees. Sine of 53.6 gives me 0.8048. Okay, so we're off a little bit, okay, because of the rounding involved in this 53.6. But really, this issue of going from ratio to angle, okay, only is when we don't have exact values. Okay, we don't really want that decimal value. Once we can do it in exact values, if I can actually express the ratio as an exact value, I express it in this way instead of using the decimal of 0.805 approximately. My calculator gives me a decimal. I want to avoid it. We only use a calculator when we need to do calculations. So this is something that you're going to have to get used to, because in grade 10, we did a lot of calculating. And we'll still do a bit of calculating, but by grade 12, we do very little calculating. And we really shouldn't be using our calculator very much at all. So when we express the cosine ratio, we could type it into our calculator, but really we should be expressing it as a ratio of adjacent side to the hypotenuse. Okay, the tan ratio, we should be expressing it as slope, opposite over adjacent, or rise over run. So here, this is a typical grade 10 problem where we're calculating something. So we're going to have to use our calculator. We don't need to rely on exact values. I have to solve this triangle. Basically, I need to find the angle A, find length Y, find length X. Okay, so I'm going to start with angle A because I know that those two angles are complementary and they add up to 90 degrees. So 55 plus 35 degrees equals 90 degrees. Once I do that, I can use either angle to solve for these sides using trig. So I know that if I want a ratio, and to be able to solve for x or y, I need a ratio. I only have one side, so I can't make a ratio using one side. So the ratio I'm going to generate using my calculator. And I'm going to do this. So I'm going to start with a sine ratio maybe. So sine, and I'm going to use 35 degrees. So sine of the angle A is going to be the opposite over the hypotenuse, which is x. And this sine 35 degrees is some decimal ratio. And now I need my calculator, because I don't know what this is. I don't have a picture that shows me the side lengths here. So I need my calculator. My calculator tells me it's 0.573. Getting around that to 0.574. So this is equal to 0.574 to 1. And this is a proportional equation. And I can just solve this proportional equation. You know, you can cross multiply. You can use a multiplier here. I can, find my multiplier going across. Here I'm just going to cross multiply this. And I'm going to end up dividing by 0.574. And so I go 6.5 divided by that number, I get 11.33. So x is equal to 11.33. And given the angle and these lengths, Yeah, that's reasonable. That's 11.33. And then I could solve for y using another ratio if I want, or I can use Pythagoras. So we have lots of options now. So once I have two sides of a triangle, I have lots of options I can work with. So I'm going to just use Pythagoras. So I'm going to say that y squared is equal to x squared minus 6.5 squared, because it's the shorter side. So I get y squared is equal to, so I'm going to square my x. So x squared, so I get 128 approximately, 0.42 minus 6.5 squared. Okay, so 6.5 squared is going to be 42.25. So I get the y squared value is 86.17. I'm solving, so I want to be able to get a value. So I can't, these are all non-exact values now. So I can't really just leave this in the square root anymore. I really should evaluate that. So when I evaluate that, I get the square root of that number is 9.28. Okay, so I get y is equal to 9.28. So I've solved this triangle. So I've solved for all the unknown sides and angles in this problem. And this is largely a calculator problem, whereas when we start talking about sine, cos, and tan as expressions, we really just should leave them as exact values.